Hello everyone, welcome back to our new video on ring theory. So previously we started a lecture series on ring theory. So if you wanted to see more videos on ring theory, you can check it my playlist. There I have uploaded so many videos on ring theory. Okay, so in my today's video lecture, I will explain ring theory and polynomial ring. My polynomial ring is more important to understand. Because of that, the rest of the topic like Galois field, again irreducibility criteria, reducibility criteria, and there are multiple type of topics which we need to understand better. For that understanding, we need to understand first of all polynomial ring, and inside polynomial ring we need to understand sum of the polynomial, multiple product of these two polynomial, how to take division of the polynomial in ring. Okay? So for that we have to learn first of all what is meant by polynomial ring. So let's get started to our new topic, polynomial ring. So you can see here polynomial ring means a ring. RB a commutative ring. Commutative ring means the property A into B which is equal to B into A. If that property hold, then we say that RB a commutative ring. Okay, and it need to satisfy other properties as well. Okay, then the set, we have set here R of X bar. Okay, so which denoted by polynomial ring. Okay, and polynomial we know that the similar polynomial here. Okay, so A0 plus A1x plus A2x square plus ANX raised to n, and all that A0, A1, A2, AN, all A1 to n which is from real. Okay, so all AI belongs to R. That is the ring in a X, okay, which is a ring with respect to variable X. Now here we have nth degree polynomial. Okay, so in your questions you will get the polynomial like a 2 degree, 3 degree, or 4 or 10 multiple type of degrees. Okay, so but here I explain here for nth degree. Okay, so we can write that polynomial as A0 plus A1x plus A2x square plus so on. All A belongs to R. Okay, so now here our main topic, it is here how to add these two polynomials. It is not like a addition like a polynomial in our regular calculations. Okay, this is the calculation under ring theory, so we have to use some certain type of the conditions. Okay, now let's get started for the sum of the two polynomials. How to find sum of two polynomials? Okay, so here sum of two polynomials, I consider here fx as a polynomial A0 plus A1x plus A2x square, and all A belongs to R. And similarly for g of x, B0 plus B1x plus B2x square plus so on, and all Bi belongs to R. Okay, so I consider here two polynomials. Now let's see how we can add these two polynomials. Okay, so you can see here their addition fx plus gx. Okay, so you have to add those variable which has the same coefficients here. Okay, so we can see here a0 b0 both are constant, so add them, a0 plus b0. So we want the fx plus gx, so a0 plus b0 plus a1 plus b1 x, it need to be a common. Okay, a1x plus b1x, that means a1 plus b1x, a2 plus b2 and outside of the bracket x square. Okay, similarly you can add an plus bn outside of the bracket x raised to n. Okay, so this is the way we can add these two polynomials. Okay, so it's easier to understand. Okay, now let's go for the product of two polynomials in a ring. Okay, so how to find the product of two polynomials? So consider, because we have to consider some finite number of polynomials. To multiply nth number of polynomial, it will take time. Okay, we just have to understand how to product of the two polynomials. Okay, so here I have two polynomials, fx which is a0 plus a1x which is belongs to ring, and g of x is here b0 plus b1x which is also we taken from R of x. Okay, that is the now R of x is a ring polynomial or polynomial ring. Okay, now let's find out how to multiply these two polynomials. Okay, inside a ring operations. So you can see here the multiplication of a two polynomial fx into gx, which is a polynomial fx here multiplied by gx here. Okay, so multiply polynomial as we do in our regular calculations. Okay, a0 plus a1x multiplied by b0 plus b1x. First multiplied by first multiplied by second multiplied by first, and second multiplied by second. Okay, so multiply it, you will get that term. Okay, so here then after of that those terms have possible, take it common, so a0 b0 remain same. So we can see here x, it is here, we can take that x common, so a0 b1 plus a1 b0. Okay, and x common here, and a1 b1 x square. Okay, so this is the way to multiply two polynomials. Okay, I explained here the polynomial who's having some finite values. Okay, finite length. So there is multiplication, it is here. So fx and gx also, it is also in that R of x. Okay, now so let's see some of the properties that a polynomial ring which hold. Okay, so you can see here the properties. I added 4 properties here. Okay, so first property is said that if R is commutative. Okay, if we have ring R which is a commutative, that means it hold property AB which is equal to BA, then it's a polynomial. Okay, R of x, it's polynomial R of x which is also having same property. Okay, it hold R of x hold the multiplication of a two polynomial with a commutative property. Okay, so it hold for R of x also. Now let's go for the next property. If R is commutative ring plus it is having unity, it has a unity element. Okay, and we all know that the unity element in ring theory. Okay, so if R is commutative ring with unity, then R of X also. Okay, then so R of X. That means that polynomial is having unity element plus it satisfy commutative ring. Okay, so and now third property is here, if R is integral domain. Okay, integral domain, what is mean by integral domain here? Meaning here, if R is integral domain, that means integral domain means we have commutative ring with unity which having property two elements, they are non-zero. That means their product also non-zero. It says that integral, which is the mean of integral domain. Or other way we can say that if the two elements, their product which is a zero, means one of the element has to be a zero, then its product is a zero. Okay, so this is the meaning for integral domain, which is commutative ring with unity. So if R is that integral domain, okay, then it's a polynomial ring. R of X also is an integral domain. Okay, R of X also integral domain. Now let's go for the fourth one. F is a field, then Fx is integral domain. Okay, if F, okay, F is a field, then Fx is integral domain, but Fx not field. Okay, we know that every field is an integral domain, but in the polynomial form, if F is a field, then Fx has to be an integral domain. Okay, and field means every non-zero non-unit element has a multiplicative inverse. Okay, so F is a field, then Fx is also okay integral domain, but Fx not a field. Okay, if F is field, then Fx not field. It is here two properties. Okay, so we can see here that four properties. I hope so you all have understood my today's lecture on a polynomial ring, which is a basic topic which we need for further understanding of the topics. Okay, so I hope so you all have understood my today's lecture. So if you have any doubt, comment me in comment box. So thank you everyone. Thank you for my today's lecture.